The following topics will be discussed in today's class. The topics are equilibrium, we will discuss definition of equilibrium, irreversible reaction, reversible reaction, physical equilibrium, chemical equilibrium, and general characteristics involving in physical equilibrium. ꯑꯩ ꯍꯧꯖꯤꯛ ꯃꯅꯤꯄꯨꯔꯤꯗ ꯑꯃꯨꯛ ꯍꯥꯏꯒꯦ ꯌꯦꯡꯉꯣ ꯉꯁꯤꯒꯤ ꯀ꯭ꯂꯥꯁ ꯑꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯇꯝꯒꯗꯧꯔꯤꯕ ꯇꯣꯄꯤꯛꯁꯤꯡ ꯑꯗꯨꯗꯤ equilibriumꯗ ꯑꯩꯈꯣꯏ definition of equilibrium tamgani ngasi class asida matang the reversible reaction, irreversible reaction, physical equilibrium, chemical equilibrium amasung physical equilibrium da involved tawduna yauriba general characteristics sing asi kari kari no habadu masa khaina ngasi class asida tamgani. Now without wasting any time, let's begin the class. Adudi hujik aikoi matam manghandana class si haunaba tawrasi. Equilibrium. Now let us discuss the definition of equilibrium. Equilibrium is a state of a process in which the properties like temperature, pressure, concentration of the system do not change with the passage of time. So equilibrium is a state of a process. At that state, the system do not change its temperature, pressure, concentration with the passage of time. That means haibagi athadi equilibrium haibasi system amana matamna passes tau targasu changes tau targasu system dugi properties sing khudam oin hairabada temperature, pressure, concentration na singba hairiba system dugi properties sing asi change tawdana leiba adugumba state phibam adubu aikoina equilibrium haina kawi. Irreversible reaction. If a reaction cannot take place in the reverse direction, that is, the products formed do not react to give back to the reactants under the same conditions, it is called an irreversible reaction. It means that irreversible reactions are those reactions in which the reaction cannot take place in the reverse direction. Reverse direction means the products formed by the reaction do not react to give back to the reactants. That means products cannot again form to the reactant. Such reactions are called the irreversible reactions. Okay, let us discuss example of irreversible reaction. Silver nitrate in aqueous form combines with sodium chloride in aqueous form gives up silver chloride in solid state with sodium nitrate in aqueous form. In this reaction, the reactants silver nitrate and sodium chloride by combining gives silver chloride and sodium nitrate. Okay, again the products sodium chloride and sodium nitrate by combining these two products in this reaction, the reactants silver nitrate and sodium chloride cannot form. So this reaction is an irreversible reaction. Now let me explain you in Manipuri also. Irreversible reaction habi atradi karigumba reaction amana reverse direction da satpangam da taragadi reverse direction adi matung halakpa direction haibani maduda satpangam da taragadi madubu irreversible reaction kawi. Reverse direction haibagi athade reaction ama thokpa matamda form toriba product sing adu punjalaga reactant amuk hanna piba ngamdraba same condition da ko adu ai targadi madubu irreversible reaction kawi. Kudam oina arbda silver nitrate ne sodium chloride ne aqueous solution oina lauraga ani se punjalaba adu ai tardi silver chloride aiba solid state si solid state form the silver chloride se pirakani salt ni mathangda masiga loinana sodium nitrate su pirakani. Hojik masigi reaction asida product oisis silver chloride ne sodium nitrate NaNO3 hai se sodium nitrate hai ni ani se ni masigi product ani se combine tawsalaga ngasagi reactant oriba silver nitrate ne sodium chloride ne ani se piba ngamde aduna masigi reaction na se irreversible reaction ni. Reversible reaction. If a reaction can take place in the reverse direction, that is, the products formed do react to give back the reactants under the same conditions, it is called a reversible reaction. Reversible reaction means if a reaction can take place in the reverse direction, that type of reaction is called the reversible reaction. Clear? Reverse direction means the products formed due to a reaction can again combine to give back to the reactants. Okay, if the products formed by a reaction can again combine to give back to the reactants, such type of reaction is called the reversible reaction. Let us see example. Calcium carbonate CaCO3. Let us take calcium carbonate which is in the solid state in a closed container, and let us heat that calcium carbonate. What will happen? That calcium carbonate will degrade, means that calcium carbonate will give two products, calcium oxide and carbon dioxide. Calcium oxide in solid state and carbon dioxide in gas state. Okay. Now again, by combining this calcium oxide and carbon dioxide, it will give back to the calcium carbonate which is reactant. So this type of reaction is called the reversible reaction. That means in this reaction, reactant calcium carbonate can give product calcium oxide and carbon dioxide, and products calcium oxide and carbon dioxide by combining again can give back to the calcium carbonate. Okay, so this reaction is a reversible reaction. Same in case of example number 2 also. By combining hydrogen gas and iodine gas, hydroiodic acid gas is given, and again hydroiodic gas is degraded and can give to hydrogen and iodine gas. Okay, so this reaction is also a reversible reaction. Same case similarly in the example number 3 also. By combining nitrogen gas and 3 mole of hydrogen gas, it can give 2 mole of ammonia, okay, gas. This 2 mole of ammonia gas can again degrade to give the reactants nitrogen gas and 3 mole of hydrogen gas. Okay, these are the examples of reversible reaction. Aduna reversible reaction habse kaino yengsi karigumba reaction amana reverse direction da amuk chatpa ngamlaba adu ai targadi madugumba reaction dubu aikoina reversible reaction kawi. Reverse direction habade reaction amada semiwe product sing aduna amuk combine toksinaraga reaction thoga reactant sing under the same condition da pi ngam targadi madubu aikoina reversible reaction kawi. Kudam moina harabda aiko calcium carbonate closed container amada lawrasi makhung khumba patra habni closed container habdi aduga hit tausi calcium carbonate to reactant ni solid ni maduna kaitharaglaga product ta calcium oxide ne carbon dioxide ne pigani. Calcium oxide to na solid ni, carbon dioxide to na gas ni. Masigi product oriba calcium oxide ne carbon dioxide to ne ani si punjalaga amuk calcium carbonate oriba ngasage reactant do pithrok pangami. Aduna product na reactant sembang ame reactant na product pibang ame asigumba reaction asibo aikoina reversible reaction kawe. Example number 2 si samane hydrogen gas ka iodine gas ka ani se punjalaga hydroiodic gas haiba ama khakpirakani mol ani khakko. Hydroiodic gas se amuk kaitharaga hydrogen gas ne iodine gas ne mol amam pithok pangangani. Aduna masisu reversible reaction amani nitrogen gas ne hydrogen gas mol ahum ga nitrogen gas mol amaga punjalaga ammonia NH3 haisi ammonia harini ammonia gas mol ani pirakani. Ammonia gas mol ani si amuk kaitharaga nitrogen gas mol ama hydrogen gas mol ahum pithok pangami. Hariba reaction sing asi close container da thokadaba ngaktani, close condition do oigedaba ngaktani, close adi makhung khumba patra da thokadaba ngaktani ko. Open condition da di yade reversible reaction sing di. Asumna reactant sing na product piba ngamaba product sing na reactant amuk hana piba ngam taraga di asigumba reaction sibo ikoina reversible reaction kawe haiba. Physical equilibrium. If the opposing processes involve only physical changes, the equilibrium is called physical equilibrium. That means physical equilibrium is that type of equilibrium in which the opposing processes involve only physical changes. That means the change in physical state. Okay, let us see by taking example. Example number 1 is solid liquid equilibrium. In this type of equilibrium, let us take an example as ice. Ice is solid state which can convert into liquid water at its melting point. Melting point is 0 degrees Celsius. Okay, this liquid water can again come back to the ice at its freezing point. Freezing point is also 0 degrees Celsius under 1 atmospheric pressure. Okay, so in this equilibrium only the change in physical state is happen, which is ice is solid state. This solid state ice can change into liquid state water. Okay, again liquid state water can change into solid state ice. Such type of equilibrium is called physical equilibrium because only change in physical state happen in this type of equilibrium. Okay, Similarly, example number 2 also, liquid gas equilibrium. In this type of equilibrium, let us take liquid water. Okay, liquid water by evaporation can change into water vapor, which is in the gas state. Water vapor in gas state can also condense into the liquid water by condensation process. So in this type of equilibrium also, change in physical state happens. That means liquid water is in liquid form and water vapor is in gas form. So liquid water to water vapor changes and water vapor to liquid water changes. That means change in physical state involved. Such type of equilibrium is called physical equilibrium. Okay, now let me explain you in Manipuri also. Aduna physical equilibrium haibadi karigumba equilibrium ama maintain tawma tamda physical changes ka thoaba adugumba equilibrium du boy kana physical equilibrium koroni khudam oina harabda solid liquid equilibrium da ice gi liquid water da on bagi aikoi example lo bayai ice is solid state ni masidagi magi melting point da ice ki melting point 0 degree celsius da liquid water da change tawba ngami liquid water dagi amuk ice da freezing point liquid water gi freezing point 0 degree celsius da amuk ice da on bangami adra melting point ka freezing point ga 0 degree celsius ngaktani atmospheric pressure na 1 leiba matam da ko aduna masigi equilibrium sida ice solid state oriba ice dagi liquid state oriba liquid water da change tawe aduna physical change ka involve tore masigi equilibrium sida aduna masi physical equilibrium ni example number 2 da haraba da subsamane liquid water dagi liquid gas equilibrium da liquid water dagi water vapor da change taba liquid water ai basi liquid state ni masidagi da water vapor hai basi gas state ni masida change taba si evaporation process na taba yai aduga water vapor gas state tagi na liquid water liquid ta change taba si masina condensation process na taba yai masigi equilibrium gi state asidasu equilibrium gi phibam asidasu masi thoiba equilibrium si physical equilibrium ni maramde liquid water dagi aikoina water vapor da change tauba amadi water vapor dagi liquid water da change tauba haibasi physical state change khadama thoi chemical equilibrium if the opposing processes involve chemical changes, that is the opposing processes are chemical reactions, the equilibrium is called the chemical equilibrium. It means that chemical equilibrium is that type of equilibrium in which the opposing processes involves chemical reactions. That means the chemical changes. Okay, such type of equilibrium is called the chemical equilibrium. Let us see example. Example number 1, calcium carbonate. Okay, it is a compound which is in solid state. Let us take calcium carbonate in a closed container and let us heat that calcium carbonate. Okay, that calcium carbonate will give calcium oxide and carbon dioxide. Calcium oxide is another compound and carbon dioxide is also another compound. Here, change in reactions means chemical changes happen. Again, by combining calcium oxide and carbon dioxide can again give back to calcium carbonate. So, in this process, the opposing process, forward reaction and backward reaction, involves chemical changes, chemical reaction. So, this type of equilibrium is called the chemical equilibrium. Okay, clear? Now, let me explain you in Manipuri also. Chemical equilibrium haibadi karigumba opposing process haibadi forward direction da satliba process to ne backward direction da satliba process to ne process anisi chemical changes to aba chemical reaction to aba adugumba makalgi equilibrium sibu chemical equilibrium kawi khudam oina hairabada calcium carbonate hairiba si compound amani solid state da leiba masi ekoi close container amada lauraga hit tawrabdi calcium carbonate hairiba compound sina atopa compound oni calcium oxide haibamne carbon dioxide haibamne tonganba compound oni pithorak pangami aduna masigi forward calcium carbonate gi calcium oxide amasung carbon dioxide ta thoiba reaction sibo forward reaction kawi aduga amuk calcium oxide ka carbon dioxide ka punjal laga calcium oxide amuk hanna pirak pangami reactant calcium oxide se amuk hanna pirak pangami masibuna backward reaction kawi aduna forward reaction dasu chemical reaction to a backward reaction dasu chemical reaction to a aduna opposing process ani si chemical reaction to abani na masigi example ase calcium carbonate gi calcium oxide amasung carbon dioxide on ba aduga calcium oxide amusung carbon dioxide punjalaga calcium carbonate pibagi reaction asi chemical equilibrium gi example amakhang. Now let us discuss some important points. Okay, point number 1, only those reactions which are in closed reactions chamber are reversible reactions, and those reactions which are in open reactions chamber are irreversible reaction. Let us discuss one by one. Okay, so let me explain you in Manipuri also. Aduna point number 1, the high risk karino haiba matamda reversible reaction se karamba reaction bu agadagi haiba matamda close condition da thokpa makhum khumba patra thokpa close reaction chamber da khaktang thokpa reaction sing da reversible reaction oigani. Karigumba reversible reaction ama open condition da thoklagadi aidi makhum khumda patra da open reaction chamber da thoklagadi madu reversible reaction oiba reaction du irreversible reaction oigini ko. Isam samna reversible reaction haibase close reaction oigedamni close reaction chamber oigedamni aduga irreversible reaction sing sidi akoi open reaction chamber da thokadamni haibani. Aduna reversible reaction point number 2, reversible reaction becomes irreversible if one of the products preferably in gaseous state is allowed to escape out. Habigi atrade reversible reaction oiramba reaction ama karigumba mana puthorakliba products mayamdugi manungda product ama hekta hena khodong chabthi gaseous state leba product ama aikoina lokthokhi tarabdi reversible reaction adu irreversible reaction oirakani haibani. Only the reversible reactions maintain equilibrium state. Aduna aikoina tamliba para se equilibrium ni. Aduna equilibrium state maintain tawba haibase reversible reaction da khak maintain tawgani, irreversible reaction da di equilibrium state se maintain tawba ngamde. So the reversible reactions do not go to completion. Aduna reversible reaction sing sidi equilibrium maintain taw lairabani na completion oina reaction do complete pok chatte haibadi reaction do reactant pomna mak product on tok te haibani. Karigino haiba matamda reversible reaction sing di equilibrium maintain taw laibani na reactant sing na product amuk ole aduga product sing do na amuk punjalaga reactant amuk on da na equilibrium maintain taw laibani na ma reaction so complete sungoi oide haibani. Point number 4, irreversible reactions do not maintain equilibrium state. So the irreversible reactions go to completion. Aina mamang da so haigre irreversible reactions sing the equilibrium state maintain tawde, reversible reaction khatani equilibrium state maintain tawriba. Irreversible reactions sing the equilibrium state maintain tawdabani na ma di irreversible reaction di reaction to complete oiba bokchat kani aduga equilibrium state maintain tawba reversible reaction sing the reaction do complete reaction thopangam de haibani. General characteristics of equilibrium involving in physical equilibrium are: point number 1, in case of liquid gas equilibrium, the pressure of the gas above liquid is found to be constant at a given temperature. And point number 2, in case of solid liquid equilibrium, the system does not lose matter to the surroundings or gain matters from the surroundings at its melting point, so the mass of the two phases remains constant. Aduna hojik aikoina tamgadori se physical equilibrium ama maintain tawleba matamda madude associate tawduna yariba involve tawduna yariba general characteristics inde kari na haba matamda ahan bigida nainodori se liquid gas equilibrium ne liquid gas equilibrium haidi liquid state ge gas state ta onba aduga gas state ge liquid state ta amuk olakpa maduda maintain tawleriba liquid equilibrium dubu liquid gas equilibrium kawi karigomba posak amara liquid gas equilibrium da leba matamda liquid tugi mathak ta leriba gas to maduge pressure ai se temperature change tawda targadi madugi liquid tugi mathak ta leriba gas tugi pressure du constant oidana lay hongdana lay change tawde haibani. Ani subagi asina in case of solid liquid equilibrium haibdi solid state tagi liquid state on ba aduga liquid state tagi amuk solid state on bagi matang sida haide solid tagi liquid on ba di melting liquid tagi solid on ba hairagana amuk freezing aduna asugumba posak amana solid tagi liquid tagi solid ta on dana equilibrium maintain tawle ba matamda hadi ba posak tuna surrounding akoi badagi sumana matter se gain su tawde aduga posak tuna surrounding da matter se loss su oide haibani hadi matter duna hadi system duna posak tuna surrounding dagi matter su gain tawde loss su oide haibani hadi ba matter si loss oidaba gain oidaba haibsi karam matam do oidagi haiba matam da magi melting point hariba temperature du khaktang da oideba maduna taba temperature sing da de mana matter loss oiba yai natraga gain oiba yai ko posak tuna aduna melting point da solid liquid equilibrium ama maintain tawle ba matam da posak tu gi melting point da posak tuna magi matter se loss oidabani na gain su oidabani na hariba phase ani sida posak tu gi mass है अरुम्ब से constant ओइदन लई होंगदन लई हाइबनी types of chemical equilibrium depending upon the phases, that means the physical states of the reactants and products. There are two types of chemical equilibrium. They are homogeneous equilibrium and heterogeneous equilibrium. Aduna hojik aikoi amuk chemical equilibrium gi type sing makhal sing amuk yangse aduna reactant amasung product sing gi phase sing haibdi makhoi gi reactant amasung product sing gi physical state ta depend tawra kanta chemical equilibrium haibasi makhal ani thona khadok pi ai homogeneous equilibrium and heterogeneous equilibrium. To discuss in detail about the homogeneous and heterogeneous equilibrium, let us wait for the next class. We will discuss in detail in the next class, okay? Aduna aikoi homogeneous equilibrium amasung heterogeneous equilibrium gi matang da amuk henna mamut ta na khangna bagi damang ta aikoi mathangi class amuk ai minasi mathangi class ta aikoi mayek sengna asa khaina masiki matang da tamsi.